Hello everyone. In this session of CCNA series, we'll discuss about TCP and UDP protocols. As we know from the TCP IP protocol suite, the transport layer is responsible for end-to-end delivery of data from the source host to the destination host. TCP and UDP are the two protocols that determine how data is exchanged over the internet, both built on top of the IP protocol. They share many similarities, but the differences make them suitable for different purposes. They are the two most widely used protocols that internet users interact with every day. Each TCP IP application typically chooses to use either TCP or UDP based on their application requirements. Regardless of which of these two TCP IP transport layer protocols the application chooses to use, you should understand the basics of how each of these transport layer protocol works. Let's say when a device or a computer wants to communicate with another device. The communication between those devices needs to be good and reliable, so we can guarantee that the data is received correctly. For example, when you view a web page or download a file or look at an email, you would expect to view the web page to be intact and in proper order with nothing missing. Or if you were downloading any file, you would want the entire file and not just some part of it. Because if any of the data is missed or out of order, then it is of no use. So this is where the TCP comes into the picture. TCP stands for Transmission Control Protocol. It is one of the main protocols used in a TCP IP network. It belongs to the transport layer of the TCP IP suite. TCP guarantees that all the data is received and in order, because without TCP, some of the data sent by the sender could be missing or out of order. For example, if you download a file, then you might not get the entire file, or you could get the file out of order, which would render the file useless. If you view a web page, without TCP, your web page could be all messed up like this. The image could be missing or the text could be backwards and out of order. So again, this is where the TCP comes into the picture. TCP is a connection-oriented protocol, which basically means that it must establish a session first between the two devices that are communicating. TCP connection establishment occurs before any of the other TCP features can begin their work. Connection establishment refers to the process of initializing sequence and acknowledgement fields and agreeing on the port numbers used. So the two devices verify a connection before any communication takes place, and it does this by using a three-way handshake. This three-way connection establishment flow, also called as three-way handshake, must complete before data transfer can begin. So the first step is that a client will send a message called SYN, used to initiate and establish a connection. The server receives the packet and responds with its own sequence number and the acknowledgement, telling the sender that it has received the message. Host acknowledges the response of the server by sending the acknowledgement back. Once this has taken place, data transfer takes place. In case if you have finished data transfer and want to close the session, fin is used to terminate a connection. Another important thing to remember about TCP is that it guarantees the delivery of data. So if the data packet goes astray and doesn't arrive, the TCP will resend it. Let's look at some of the common applications that uses TCP, starting with FTP, SSH, Telnet, SMTP, and HTTPS. Next, let's have a look at UDP. UDP is very similar to TCP. UDP is also for sending and receiving data. UDP is a connectionless protocol, which means it does not establish a session and it does not guarantee data delivery. So when a computer sends the data, it does not really care if the data is received at the other end, and that's why UDP is known as the send and forget protocol, because it sends the data and it does not really care what happens to it. UDP can be used in an application where speed rather than reliability is critical. UDP is faster than TCP because of the less overhead, that is involved of not guaranteeing data delivery. So let's look at some of the common application that uses UDP, starting with TFTP, NTP, Syslock, RGSP. Let's have a brief comparison between TCP and UDP. TCP is a connection-oriented protocol, whereas UDP is a connectionless protocol. TCP guarantees that no packets are missing and all the data that send makes it to the internet recipient. UDP allows missing packet. The sender is unable to know whether the packet has been received. TCP sends packet in order, so they can be stitched back together easily. UDP packets don't necessarily arrive in order. TCP is slower and requires more resources. UDP is faster and needs fewer resources. TCP is best suited for apps that needs high reliability and transmission time is relatively less critical, whereas UDP is better suitable for application that needs fast, efficient transmission such as games. TCP is the most widely used protocol in the internet, whereas UDP is used for VoIP, video streaming, gaming, and live broadcast. That's it about